And so what we came up with was this methodology, this urban tree canopy assessment. And as I mentioned before, it's really just high-resolution feature extraction. Okay, and we came up with a method in which we compute what we call two metrics, right? We could name these easy things, but it's all about branding in today's world, and so we came up with two names, or two terms, if you will. One is existing UTC, and that's any piece of land that's covered by tree canopy. That's your current tree canopy. And then we also call the other metric possible UTC. That is, where is it biophysically feasible for you to plant trees? Okay, how much land do you have available for trees? Not that it's either socially desirable or financially feasible to plant the trees there, just where you have the space to do it. And just to show these graphically, obviously existing UTC displayed on some panchromatic imagery here. That's all your trees. And by the way, if you're working with communities, you better map all their trees, not just the big patches. And then we have the possible UTC. Once again, the land that's available for tree planting. So the vegetation, all your grassy and your shrubby areas, and then also impervious areas. So those road edge, non-building areas where you could establish tree canopy. And people are rather surprised when we include impervious in there, but if you go down to cities like New York, you can see they're making major changes to their impervious landscape. They're going in and they're digging up these roads where they had the zebra striping before and cars don't drive on. They dig them up and they're establishing tree canopy on them. So that stuff's all fair game. If you go down to Baltimore and you want to build something new, you want to pave over an area, okay, there are laws that require you to find another area you better dig up and regreen in order to keep the balance neutral. So what do we provide to decision makers? Well, when we generate high-resolution land cover, we can actually tell them the land cover metrics for their city. If you go around to most communities in the United States right now, and I think this is fair to say worldwide, and you say, how much impervious surface do you have? How much tree canopy you have? How much agriculture is in your city? Yes, there's agriculture in our cities. You ask them that on a percentage basis, you'll find probably 0.3% actually have that knowledge available to them. Okay, but in our case, we want to specifically give them these UTC metrics. Okay, that is, we want to tell you how much tree canopy you have right now, and then the possible UTC. Okay, how much land you have available, and we want to give that information so that decision makers can say with confidence, we're going to establish an urban tree canopy goal for this specific amount. And because this is geospatial information, we can take it and integrate it with our other geospatial data sets, such as parcel land use, and summarize this data in a way that it becomes actionable intelligence for implementation. And this is very important. If most of the land available in your city for tree planting is in a government-owned area like a park, well, your implementation program is going to be dramatically different. That's government land. They can just go in and plant trees. When you start doing the analysis and you start to see that not only do your residents have most of your trees, but they have most of the land available for trees, okay, you can't just go into people's yards and plant trees. You have to convince them to plant trees. And you also better convince them to keep the trees they have. Okay, and if they don't do that, what's going to happen? You're going to have increased stormwater runoff, your costs are going to go up. So this is very important when it comes down to the implementation. Once again, giving people actionable intelligence.